For more than 60 years, CCI has delivered end-to-end solutions for communication networks serving clients nationwide. We combine forward-thinking engineering and the latest technology with practical field experience to plan, meet, and exceed our customers' expectations. CCI Systems is a bridge between disparate, overly complex networks of the past and an operationally efficient network of the future. We use our combined telecommunications experience, comprehensive network assessments, industry-leading mapping design and engineering, and an in-depth consulting to discover and solve customers' most complex business and technical challenges. Our 24/7 US-based contact center and network operations center are quick to respond and proactively resolve issues so you don't have to. We don't just sell part numbers or widgets, we engineer solutions for you.
Welcome to CCI's Make Life Better podcast. I'm Joe Smith from CCI. I'm the marketing guy, and we're fortunate today to have with us Gene O'Neill from CCI. And Gene's a product sales specialist with CCI. And one of the unique things I've been looking forward to talk to Gene with is Gene goes around the country and talks to a lot of different operators. And it's only for a couple days, Gene, but maybe an afternoon. But you get into some pretty great information and detail wrapped around DOCSIS. Let's just start there. Like, kind of tell us about that engagement you do with operators and how that turns out for them.
Sure. Okay. So the latest iteration of DOCSIS is DOCSIS 3.1. The fifth iteration since 1997. The previous legacy versions of DOCSIS being DOCSIS 1.0, 1.1, 2.0, 3.0, and 3.1. And so and ironically, at this point in time, the DOCSIS 3.1 specification is 7 years old. The DOCSIS 3.1 was completed in 2013, actually August of 2013. So just a month ago was the 7-year anniversary of the specification. So a lot of operators have already deployed DOCSIS 3.1, and some operators have deployed it to a much greater extent than other operators. And so there's a wide spectrum of operators that are trying to take advantage of the specification, which is a really good idea. If anybody has any experience at all with DOCSIS, whether it's 1.0, 1.1, 2.0, or 3.0, they know and understand the power of delivering data over an HFC infrastructure. So DOCSIS being the data over cable system interface specification, the equipment is built according to that specification. And so 3.1 is really, at this point in time, in my opinion, a masterpiece work of the DOCSIS engineering committee and the engineers that made the contribution at Cable Labs to create the DOCSIS specification. I've been around long enough that back in 1997, when DOCSIS 1.0 was first released, and believe me, DOCSIS 3.1 is much more sophisticated than that original DOCSIS 1.0. As a matter of fact, it's more sophisticated, as you would expect from DOCSIS 3.0. So I take advantage of the opportunity to work with our customers, to talk to them, to try to educate them about the DOCSIS specification. We could take anywhere from a 2-hour seminar to 4 hours, a full day, 2 days, 3 days. DOCSIS 3.1 is a lot of information. There's a lot to talk about. But what I've been doing recently is been working with the cable operators to deliver about a half a day, probably, what we refer to as a technical seminar, a DOCSIS seminar. It's a great introduction to the DOCSIS specification. Obviously, most of the information we want to talk about is DOCSIS 3.1. But I talk about the fact that every single version of DOCSIS, every iteration of DOCSIS has a reason to be, right from the very beginning. And the reason that DOCSIS 3.1 exists is to wring out the very last capabilities of an HFC infrastructure, which is pretty interesting when you think about it, because not only do we have DOCSIS 3.1, but they're working on DOCSIS 4.0. So I thought that 3.1 was it, that we were just going to create DOCSIS 3.1, wring out the last capabilities of the HFC infrastructure, and then be done with it and move on to a fiber solution or whatever what the next technology is. So Well, with that in mind, we talk to the cable operators and we tell them that, listen, you already have an HFC infrastructure, you have plans for that, you have goals and aspirations for your telecommunications network, and why not take advantage of your existing HFC infrastructure, because that's why DOCSIS 3.1 was created in the first place, was to protect your long-time, very, very expensive investment in that HFC architecture. So we talk about what is the reason to be for DOCSIS 3.1, and then how does DOCSIS 3.1 work? How are the goals reached? Which by the way, the goal of DOCSIS 3.1 is to have a multi-gigabit per second downstream service and at least a 1 gigabit per second upstream service available. And believe me, DOCSIS 3.1 does that and more. It's very, very unlikely that anybody would ever be able to deploy a fully operational DOCSIS 3.1 network at its full capabilities, which would be in excess of 20 gigabits per second.
Wow, you said a lot there, and you did it quickly. I remember, so my history in the industry, I've heard the same thing as you, as far as this is it. Fiber to the home, fiber's taking over, squeeze everything you can out of the HFC plant because that's it. And now, like you said, and that was probably 20 years ago, the end was coming. And now I just can think of one customer that was competing with an overbuilder, fiber to the home, utilized their HFC plant, did mid splits and got the upstream bandwidth increased, and that thing is humming as fast as the fiber to the home system, and they're in business and competing and getting more customers. So I think you're right on with that. Got
yeah,
some
exactly.
time to go here.
I'm thinking about one of our customers that had some competition in the geography where they're a service provider, and the competition was about to offer a 1 gig service over fiber, or at least they were planning on building out infrastructure to be in a position to do that. And our customer went ahead, did a DOCSIS 3.1 upgrade, and immediately, in a very, very short amount of time, had a 1 gigabit per second offering, and the competition just shelved their plans. They weren't going to make the investment to try to compete with another service provider. It just would have been too expensive, and they didn't have HFC infrastructure where our customer did, and they utilized that, leveraged that, built the 1 gig service, and just with the competition went home.
Yeah, I think the same story. Maybe it's the same customer, but yeah, it is amazing the amount of savings that HFC operators can utilize in this type of technology. And the next question, of course, then becomes, what about that 4.0? How many more capabilities is that going to give us? But that's probably for another day.
It is, and in my opinion, the jury's still out on that. There's a lot of talk in the industry. There was a Light Reading just had a technical forum to discuss the future of HFC. They talked about 4.0. The panel members talked about 4.0. They talked about 3.1, and the consensus in the room was that the runway for DOCSIS 3.1 was another 10 to 15 years, and that the cable operators could look forward to leveraging their existing HFC infrastructure for at least 5 to 10 years. But I think the consensus was more like 10 to 15 years, and get a lot of bandwidth out of that existing infrastructure. And it's extraordinarily interesting because the operator does not have to upgrade their HFC system in order to make DOCSIS 3.1 work. They could put 3.1 work in an existing, put 3.1 to work in an existing HFC environment, and and continue to operating any improvements without making any changes to their bandwidth, to the quality of their HFC infrastructure. DOCSIS 3.1 was designed for that. Now, of course, if you're going to take full advantage of 16K QAM or even just 4K QAM, then your modulation error ratios, your SNR, all of these things come into play, and those are the gating factors of whether or not you can take full advantage of 3.1. That's why I said that full advantage is really actually depending on having a 5 to 204 high split upstream and a 258 to 1.8 gigahertz downstream with 8 max-sized OFDM blocks, occupying all of that downstream bandwidth, and using 16K QAM across every single subcarrier. That's a tall order. That's not going to happen. It happens in the lab, but it won't happen in anybody's infrastructure. And so therefore, there's always room for growth. There's always room for improvement. And if any operator wants to make improvements and make enhancements to their infrastructure, then they can start to push the envelope and potentially use 8K QAM or 16K QAM, at least in parts of their infrastructure. And what we're seeing is that it's very, very likely and very possible to utilize 4K QAM in a properly maintained and aligned, properly swept and balanced HFC infrastructure.
Got it. I think, Gene, you come across with a lot of energy and a lot of knowledge. Before we get into the actual common questions typically asked in your seminar, just tell us a little bit about Gene O'Neill, background, industry, knowledge, and where you're located, what's going on in your life today.
Sure. So I was Air Force, United States Air Force, from 1981 to 1985, and I learned RF electronics. I returned home after my 4 years in the Air Force to Boston, Massachusetts, and I got a job with a small company that sold a campus-wide networking technology to their customers. And that campus-wide network technology was a broadband system. It was a coaxial system. Required two-way capabilities, and usually that meant a dual cable system, not a single with a return and a forward. And so the job that I had was to be a bench technician, and I owned a QPSK modem, which was one card in a series of cards that all fit into a card cage and plugged into a backplane. So that was ancient technology compared to what we have today. But in the late 1980s, and this gets into a little bit about where DOCSIS comes from, actually, but in the late 1980s, Digital Equipment Corporation called and asked us if we thought that our product would work in a commercial CATV environment, and we said we thought it might, but we would be willing to do a proof of concept. So we did at Continental Cablevision in Boston, and proved the concept of providing data communications. And by that time, the interface on our box was Ethernet. And so we were not exactly pushing Ethernet 10 megabit per second, but the interface on the box was an Ethernet 10 megabit per second twisted pair 10 base T. And so we proved the concept. We entered into an agreement with Digital Equipment Corporation, and we built our first product and started to deploy it around 1991 maybe, and had success in a commercial environment. Around 1992, that company that I was working for, Land City, upgraded, and we built our second generation product, and we were no longer associated with Digital Equipment Corporation. And we deployed a personal modem to many, many, many customers across the globe. We had about 45% of the marketplace. Motorola had about 45%, and then other small companies had the rest. But the industry was sold on the fact that we could provide data communications over their commercial CATV infrastructure. And then in 1992, of course, the internet took off, and now cable operators could become ISPs. So I saw the handwriting on the wall. I went to school at Northeastern University, learned everything I could about data communications, added it to what I already knew about RF electronics, and then went in the field as a field engineer, working with companies like Cablevision and Comcast and Media One and Roadrunner back in those days. Mm-hmm. Old names, those companies are long gone. And so I worked with them, helping them to deploy that technology. And I ended up doing a lot of training, a lot of data communications training, a lot of modem training for our customers. And then in the mid-1990s is when the industry decided we need a specification, because obviously these other products that we're using are proprietary products. And so they commissioned the creation of the DOCSIS specification through Cable Labs. And it didn't take very long that once that was completed, that I had obviously had to make that shift from working with a proprietary solution to working with DOCSIS solutions. Mm-hmm. And in 1999, I started a company and became the first Cisco partner that was dedicated in the cable television space, the commercial CATV space. So did a lot of work with the old UBR 7246s, 7223s. Then, of course, the UBR 10K came along, and the RF Gateway 1 and the RF Gateway 10 with DOCSIS 3.0, and then the CBR 8, of course. And so it's been a long career. That obviously back to 1985 is 35 years ago. And with DOCSIS, it's been the full 23 years of that history. And I'm real happy now. I got a fantastic job working at CCI Systems, working with some real geniuses. Todd Gingras, his cousin Yuli, Chad Kay, Stu Latte, Nate Zerwan, Ian, and others. Just, as good as they come. And it's a real pleasure working here now.
It's funny you bring up all those names, and there's many more, but the last conversation I had with some of those names you just mentioned, we were talking about RF engineers, and it's hard to come by that kind of talent, let alone the amount that we have combined with the IP side and everything else that we have going. It puts us in a rather unique position to provide a different level of expertise, engineering expertise, real world HFC plant knowledge, in combination with everything IP to make this thing really, really work. So, we're making a point of sharing that because we've just run into different SPs out there that say and tell us their story of how hard it is to find RF expertise in combination with everything else. So,
yeah, exactly.
I can mention that.
So, like I mentioned, this is now a 35-year-old career. For the past 25 or 30 years, it's been involved with the cable modem technology, a proprietary solution, now the DOCSIS solution. Mm-hmm. And I've told many students that sat in my classroom that this is a marriage of two technologies. It is data communications technology, routing, switching, Ethernet, all of that data communications and the necessary security and other applications that come along with it to be an ISP, right? And now all of that technology is married to RF telecommunications, understanding that HFC infrastructure and how does data communications get accomplished over an HFC infrastructure. It's marrying all of this technology together. And so CCI is one of, it may be the last company. I'm not sure exactly who our competition would be in terms of what we do, the expertise in both realms, both in terms of trusted critical infrastructure for routers and switches and security. And nowadays it's all of the network operations, the virtualization, the orchestration, all of those things that are going on at our customers, which are all service providers, right? And then
I don't think you're too far off, because it's actually my job to figure out who we compete against, and the way we just described it, I think that list is pretty close to. I can't find it from end to end like that. So you're right.
Yeah, so that's why this has been a great fit for me to come along and to be able to work with CCI, because this is the industry that I've been working in for a very, very long time. And it's, I'm really happy to be here. And the talent is exceptional on both sides of the house in terms of the technology. We have the necessary CCIEs with full routing switching capabilities. We have the necessary outside plant technicians and engineers, inside plant technicians and engineers. Is there anybody better with the CMTS than Todd and Yuli Gingras, right?
I'll say no, but enough about us. It's easy to brag about us. Let's get down to some of those questions. So if you're listening to this now, you can clearly see the level of expertise and experience with Gene is accepted in so many of these environments within operators because of what you've already explained. So we just put together a quick list of some of the common questions that you get out of those seminars. And the first one being, what is OFDM and what is the difference between OFDM and QAM modulation?
So that's a really good question, because I've heard a lot of conversations, I've read articles, and there seems to be some basic level of confusion across the industry. about, because this OFDM, for example, orthogonal frequency division multiplexing, is new to DOCSIS. We didn't use orthogonal frequency division multiplexing prior to DOCSIS 3.1. We've always used, the cable television industry from its inception 70 years ago has always used frequency division multiplexing, right? But now we have this orthogonal frequency division multiplexing. So OFDM is that. It's orthogonal frequency division multiplexing. And it is a certain flavor of frequency division multiplexing. And there's so many people in our industry that understand that, so that when I can sit in this seminar and start to talk about what's the difference, they're smart people, of course, right? They're engineers and technicians working with high technology. So you start talking about frequency division multiplexing, which they know all about, and then just say, well, this is what orthogonal frequency division multiplexing is. There's a bit of a difference between the standard 6 megahertz channel lineup that everybody's so used to. And now we talk about OFDM blocks. Well, that just means that we have a block of subcarriers that are spaced at either 25 kilohertz or 50 kilohertz, as opposed to SC QAMs, single carrier QAMs, which are spaced out across the spectrum in 6 megahertz increments. And so the whole idea of using orthogonal frequency division multiplexing gives a more efficient use of the bandwidth. Many subcarriers across a given amount of bandwidth, and that given amount of bandwidth can be anywhere from, in the downstream spectrum, anywhere from 24 megahertz all the way out to 192 megahertz in increments of 25 or 50 kilohertz. And there's a certain amount of immunity to MER, SNR, low MER or low SNR, an immunity toward interference, immunity towards some suckouts in the infrastructure, caused by flaws in the cable. It really boils down to mismatches, impedance mismatches in the drop cable or in the trunk cable or the feeder. Maybe there's a problem amplifier or a diplexer or something like that. And so utilizing a bunch of subcarriers as opposed to a single carrier in an SC QAM gives us a relative immunity. And so we don't have an awful lot of time right now, obviously, to dig into that, but that's the kind of a thing that we would address, is that, well, how does orthogonality work? How is orthogonality achieved? And then what is the benefit of it? And then we could talk about QAM modulation and compare it to that. Modulation is modulation. Modulation is not multiplexing. So when we talk about OFDM, it is multiplexing. It's multiplexing subcarriers together as opposed to multiplexing SC QAM channels together. And then when we talk about modulation, we talk about QAM modulation. QPSK is a very, very basic QAM modulation. It's the exact equivalent of QAM 4. In the downstream infrastructure of a DOCSIS 3.0 system, you're almost certainly going to find QAM 256. You might find QAM 64, but I've never actually seen QAM 64 utilized. So QAM 64 is a little bit more complicated than QAM 64 or 32 or 16 or QPSK. And so therefore there's more bits per hertz as a result of using a more complicated modulation technique. And the benefit the benefit in use of QAM modulation in DOCSIS 3.1 is that we have a QAM modulator and QAM demodulator on a per subcarrier basis. So in some instances, there may be as many as 6,000 or 7,000 subcarriers in an OFDM block. And every single one of them is, in the downstream, we're talking, every single one of them is modulated with one of 12 different modulation techniques, anywhere from QAM 64 all the way up to QAM 16384, 16K QAM, or somewhere in between there. And the more complicated the QAM modulation technique, the more bits per symbol, which means you get more bits per hertz. So again, in the classroom, at the whiteboard, a full explanation of how do you get from this particular version of QAM 64, let's say, or 256 to QAM 4K, 4096. And what's the benefit of doing that? And how many bits per hertz is achievable? And how many, in 4096 there's 12 bits per symbol, and 1024 there's 10, and 256 there's 8. So you start to see these numbers, and it starts to take on meaning. None of it is too terribly complicated for a smart engineer technician that we find in our industry. It's just something that they haven't been used to in the past, especially if they've been working with the other versions of DOCSIS, because we were limited to QAM 256 in the downstream. We're no longer limited to 256 with DOCSIS 3.1. There's much, much more advanced modulation techniques available. And so these are the things that we talk about. I
gotta believe, like, if you go to class with a pencil, you better bring a sharpener. Because everything you just said, I mean, you gotta run out of ink. And I'm not one of those engineers, so I'm just going, wow. It's gotta be valuable.
There's a lot to it, and I love teaching. I love getting in front of the customer and explaining all of these things. And like I said, our industry is filled with smart engineers and technicians, so they soak it up. They do. They bring their notebooks, they bring the sharpened pencil, they take a lot of notes, they ask a lot of great questions. And, and at this point in time, most of every operator has some exposure to it. So they come with questions, right? And they ask me questions about this, that, and the other thing. And we do our best to answer all of those questions, utilizing the experience that we've had in the past, and then in our understanding of what the DOCSIS 3.1 spec is all about.
Well, here's another one for you. What is the significance of modulation profiles?
So I already mentioned that in DOCSIS, all versions of DOCSIS, 1.0, 1.1, 2.0, and 3.0, all the legacy versions of DOCSIS prior to DOCSIS 3.1, there were two options for QAM modulation in the downstream infrastructure, and that was QAM 64 and QAM 256. What the industry found very, very quickly was that QAM 64 was extraordinarily easy to accomplish in an existing HFC infrastructure, in the downstream of an HFC infrastructure, because the cable operators made their money. They produced their product and delivered it. They trunked it, delivered it, and distributed it using the downstream infrastructure. That means that HBO and Showtime and Cinemax and ESPN and CNN and all of those programs were delivered to their customers via that downstream infrastructure. So when the DOCSIS specification was created, it was created utilizing the existing technology, and one of those things would be a standard 6 megahertz wide downstream. I'm talking standard for North America. It would be an 8 megahertz in Europe, right? But in North America, standard 6 megahertz wide downstream channel. And in those days, in those early days, there were analog channels, so there were three carriers in each one of those channels. So what the DOCSIS specification did was it made use of that, but did not create an analog channel, but created a digital channel. And as a result of a digital channel, there was a single carrier in the dead center in the middle of the 6 megahertz wide channel, right? And that carrier was modulated with either QAM 64 or QAM 256. And like I just got done saying is that QAM 64 was extraordinarily easy to use. And so the only other option was QAM 256. So every single operator worldwide for year after year after year was utilizing QAM 256 as their modulation technique. That was their one and only modulation profile available to them. Now, obviously, QAM 64 was available, but it really wasn't. It was just too easy to accomplish. If you couldn't do something with QAM 256, you had a problem that was readily obvious and easy and pretty easy to fix. So it was addressed immediately. There was never any option of just falling back to QAM 64. So that's why I say the only real modulation profile was QAM 64. Well, now, with the addition of DOCSIS 3.1, it's not only QAM 64 and 256, but it's QAM 64 all the way through in powers of 2 up to QAM 16384. So that would give you obviously 64, 128, 256, 512, 1024, 2048, 4096, 8192 and 16384. And
that's exactly what I thought. I was doing that calculation. Yep, you got it right.
And so you obviously have a slew of modulation techniques to choose from. And so as each one of our OFDM blocks is modulated with the different modulation techniques, which modulation technique to utilize is decided by the operator, there's multiple different modulation profiles. And also because each one of those subcarriers that are found in the OFDM block is individual and independent, orthogonal to every other subcarrier, every one of them can be modulated with a different modulation technique. Now, we don't find that very often. We find a span of subcarriers that will be modulated with let's say QAM 256, and then another span modulated with QAM 512. The goal is, today's goal is pretty much uniform across the board, is to use QAM 4096 as much as possible. But that is not always the case. But this is the flexibility of DOCSIS 3.1, is that these OFDM blocks can be set up, and the number of subcarriers can be chosen, making the most efficient use of the bandwidth available. And then each one of the subcarriers is optimized to utilize the best modulation technique that it possibly can use, and thereby grooming these OFDM blocks to suit the cable operator's infrastructure and getting the most out of that infrastructure. And as I said in the beginning, that's what 3.1 is all about, is it's squeezing the very last capabilities of the HFC out in order to achieve multi-gigabit per second service in the downstream and 1 gigabit per second. And so making full use of the modulation profiles is the key to achieving that goal.
I think I got it. Wow. So listen to this one. We know a lot of operators come to your seminars, see obviously an abundance of information, walk away knowing they have questions because they took all those notes with that number 2 pencil.
Right.
It's dull now, but they probably don't quite know what to ask. So in your mind, what should those operators be asking to check their network for? 2 things, both DOCSIS 3.1 readiness and also to check if their DOCSIS 3.1 system is being used to its full potential? How do they go about doing it?
Right. The bottom line in all locations is that what is your MER? And so for a long time, cable operators have had a more than sufficient modulation error ratio, MER, in order to support QAM 256. Well, the requirements to support QAM 512 or 1024 or 2048 or 4096 are greater. The requirements to support the more advanced modulation techniques are greater than what they were to support QAM 256. Now, in a lot of instances, the operator has maintained their infrastructure very, very well, and so that they already have the capability of supporting QAM 4096, but they may not be able to. So one of the number one things that an operator that wants to deploy DOCSIS 3.1 or get the most out of 3.1, the number one thing that they need to be concerned with is that what is the modulation error ratio on there? And there's a lot of contributing factors that can contribute to a lower modulation error ratio, which would prohibit them from reaching full potential, right? And so understanding the condition of their outside plant would be the number one concern of any operator. And that's to take full advantage of DOCSIS 3.1. That's not to utilize 3.1. DOCSIS 3.1 will work in, practically speaking, any two-way HFC system, especially if they have any version of DOCSIS running in it already. It is not as if that the infrastructure needs to be upgraded, that it needs to be improved, that the operation of it needs to be improved in order to operate 3.1. That's not the case. They could deploy 3.1 immediately, and it will work. When you start to optimize the plant for that proper MER, that's when you're taking full advantage of DOCSIS 3.1.
So in CCI, Oh, sorry, go ahead.
I was just going to say, and so that's where that's where when they're walking out and they have a good understanding, they need to understand that first, and then number two, almost just as importantly, is that how do they take advantage of the modulation profiles?
Understood. And then CCI, I was going to add, has a readiness assessment, correct?
Exactly, right. So we have a number of different assessments, right? There's a head-end assessment, there's a readiness assessment, there's an outside plant assessment, and some of them are a little bit easier to achieve than others, like the saturation assessment is a fairly easy assessment for us to accomplish, where we are able to assess how their current equipment is operating and how what kind of improvements could be made to either upgrade to 3.1 or to improve the operation of an existing 3.1. But the one that would be related to finding problems in their system to alleviate those problems in order to get the most out of 3.1, that would be the outside plant assessment. Right. And we have obviously the necessary expertise to do that. And then closely associated with that outside plant assessment is also a program that Chad and Stu have developed, which is called the targeted sweep, which is an alternative to 100% full sweep and balance of an HFC infrastructure. We've got a plan and a program to eliminate 90+% of the problems in an HFC system by targeting the sweep and not doing 100%, but rather somewhere between 30 and 50% sweep. And
I can imagine huge savings in that.
And we have some excellent success stories of working with our customers to get that done.
That's right. Very good. Last question. What should be in front of mind for operators when they are looking to deploy DOCSIS 3.1?
Front of mind is, finding the right vendor that suits them, of course, right? Everything we at CCI, we like to think in terms of solutions as opposed to just in particular, products specifically. But so you want to have the proper solution when you're entering into this arena. In the number one and close number two would be selecting the correct CMTS for your operation, and does it scale well? Do you know how many subs that you have? What do you plan on in terms of capacity? What are your licensing concerns? All of those things are addressed by the CMTS vendors, and then closely related to that, obviously, would be cable modems, because clearly the end user, the subscriber, the customer of the cable operator has to have a modem in place at the end of that drop cable in order to take advantage of it. It has to be a 3.1 modem. You're not going to operate at 3.1 without a 3.1 modem, right?
Yeah.
And then another thing we talk about outside plant, a lot of the focus in 3.1 has been is on the downstream, and you can operate a 3.0 and even 2.0, but there's not an awful lot of 2.0 infrastructure out there. Most all infrastructure these days is DOCSIS 3.0 or 3.1. You could operate DOCSIS 3.0 in the upstream and 3.1 in the downstream and mix those two together. And so therefore you could have a plan to just deploy DOCSIS 3.1 in the downstream only and leave leave the upstream for later. So that would be another thing that would be in the mind of the operator is that, are we going to do that? Are we going to deploy just the downstream? And that usually is the case. I don't even know if I've ever seen anybody deploy downstream and upstream simultaneously. Usually it's the downstream first, followed by the upstream. And then once you start talking about the upstream, now you want to make sure that you have the proper bandwidth, taking full advantage. And so therefore now you have to start considering doing a mid-split or a high-split upgrade of the upstream bandwidth, right? Another thing to be concerned with in front of mind for the downstream deployment of the equipment is, where are you going to put the channels? How many channels are you going to deploy? And what is the width of those channels, right? And then there's a lot of details that go into those questions. Once those questions are answered, there's a lot of details, and that's part of the seminar, right? Is we talk about the specific details. There's just a number of different things that have to be addressed in the deployment of the technology.
So everybody, Gene O'Neill, you can tell, has plenty of information and knowledge to share with you guys. Just an unbelievable resource that you should take advantage of. Give us a call if you heard anything here today that even came close to piquing your interest. Gene has a lot more to share with you. So, Gene, thank you very much for joining us today. It was very enlightening, to say the least.
My pleasure. Glad to help you.
Very good. There you go, everybody. Gene O'Neill with CCI Systems. And, of course, I'm Joe Smith from our marketing group. Until we talk again. Oh, and don't forget, check out ccisystems.com for the whole suite of assessments. As Gene said, great place to get started with how you're going to approach DOCSIS 3.1 and beyond, and get more information on how to make contact with any one of us. We'll be happy to help. Until the next podcast, we look forward to talking to you soon.